Measurement of matter. Law of constant proportion. In 1794, the French scientist J. L. Proust stated the law of constant proportions as the proportion by weight of the constituent elements in the various samples of a compound is fixed. For example, the proportion by weight of hydrogen and oxygen in water is 1:8. This means that 9 grams of water is formed by chemical combination of 1 gram of hydrogen and 8 grams of oxygen. Similarly, the proportion by weight of carbon and oxygen in carbon dioxide is 3:8. For example, in 44 grams of carbon dioxide, there is 12 grams of carbon and 32 grams of oxygen, so that the proportion by weight of carbon and oxygen is 3:8. Atomic size. We have learned that at the center of an atom is the nucleus and that there are moving electrons in the extranuclear part. The electrons are negatively charged elementary particles, while the elementary particles that make up the nucleus are positively charged protons and electrically neutral neutrons. Look at the image of iridium atoms obtained with a field ion microscope. The size of an atom is determined by its radius. The atomic radius of an isolated atom is the distance between the nucleus of an atom and its outermost orbit. Atomic radius is expressed in nanometers. The table below shows approximate size of an atom. For example, atomic radius of hydrogen atom is 10 raised to minus 10 meters. Atomic radius of water molecule is 10 raised to minus 9 meter, and atomic radius of hemoglobin molecule is 10 raised to minus 8 meter. Here 1 upon 10 raised to 9 meter is equal to 1 nanometer and 1 meter is equal to 10 raised to 9 nanometer. Do you know? Atoms are very tiny. Modern instruments like the electron microscope, field ion microscope, scanning tunneling microscope have the capacity to show enlarged images of the atom. Atomic size. Atomic size depends on the number of electron orbits in the atom. The greater the number of orbits, the larger the size. For example, an atom of potassium is bigger than an atom of sodium. If two atoms have the same outermost orbit, then the atom having the larger number of electrons in the outermost orbit is smaller than the one having fewer electrons in the same outermost orbit. For example, an atom of magnesium is smaller than an atom of sodium. Mass of an atom. The mass of an atom is concentrated in its nucleus, and it is due to the protons and neutrons in it. The number, that is proton plus neutron, in the atomic nucleus is the atomic mass number. Protons and neutrons are together called nucleons. An atom is very tiny. Then, how do we determine its mass? Scientists too struggled with this question. It was not possible for scientists of the 19th century to measure atomic mass accurately. Therefore, the concept of relative mass of an atom was put forth. A reference atom was required for expressing the relative mass of an atom. The hydrogen atom, being the lightest, was initially chosen as the reference atom. The relative mass of a hydrogen atom, which has only one proton in its nucleus, was accepted as 1. Therefore, the magnitude of the relative atomic masses of various atoms became equal to their atomic mass number, that is proton plus neutron. Let us see how to express the relative mass of a nitrogen atom. having accepted the relative atomic mass of hydrogen as 1. The mass of one nitrogen atom is 14 times that of a hydrogen atom. Therefore, the relative mass of a nitrogen atom is 14. This is how the relative atomic masses of various elements were determined. On this scale, the relative atomic masses of many elements came out to be fractional. Therefore, in the course of time, different atoms were chosen as reference atoms. Finally, in 1961, the carbon atom was selected as the reference atom. In this scale, the relative mass of a carbon atom was accepted as 12. The relative atomic mass of one hydrogen atom compared to the carbon atom becomes 12 into 1 by 12, that is 1. The mass of one proton and of one neutron on the scale of relative atomic masses is approximately 1. Today, we have highly accurate methods for measuring the mass of an atom directly. Hence, instead of relative mass, unified mass has now been accepted as the unit of atomic mass. It is called Dalton. Its symbol is U. Therefore, 1 U, that is 1 Dalton, is equal to 1.66053904 into 10 raised to minus 27 kg. Thank you.